In this video, I'm going to show you how to graph any function. As gross as Eddie Wu likes to say on YouTube, who's one of the best math professors in my opinion, this is like a gross function right here. It's not something that you're typically accustomed to. It could be a little intimidating. So we're going to cover a really quick process and very logical procedure as to how to go about graphing gross or very complex functions. So what you do is, number one, you first want to identify who's the parent, who's the dad, who's the mom. So this is your anchor point. And anchor, I often reference this analogy in all my videos explaining. I like to have anchors in my mind. So if I'm thinking here, and I have this anchor in my mind, and it all builds from there. That's the basic building block. And this anchor is going to be your parent functions. These are functions we've seen since we're like 11 years old. So you need to be familiarized with what these are. They're not that many, and most of us already know them. If you don't, then know them. Once you got that anchor, then you can move on to this step. So you found the complex function, which looks very intimidating, and you ask yourself, how do I even approach this? Where do I start? Very simple. We're going to do an x and y axis graph. All right, very simple. We've done this since we were kids. So this is a trigonomic function. We're going to start out with the parent function, sine x. And if you're familiar with the unit circle, great. We're not going to cover that in this video. So you just plug in the x value. You plug in 0 into the x, and you get 0 over here. Once you plug in pi over 2, you get 1 over here, so on and so forth. Now you graph that, and that will be the red line that you see in the graph. Imagine that the other colors are not there, okay? Now this is the beautiful process that I want to show you. You add another column here on the right. Maybe you could do a different color. We use green here. And you add this is the golden nugget, pay attention. You add just one little bit of complexity to this column. So see how we graphed sine x? We're just going to add the half inside the parentheses. That is all we're going to add. That's the only difference between column number 2 and column number 1. So this 1/2 that we put right there. So let's run it again. We're going to put the 0, the x value, we're going to put it in there. And we're just going to run the function. So 1/2 times 0 is still going to be 0. So there's like a little equal sign there. And the y value ultimately ends up being 0. So that is the value corresponding to this function. Let's do another x value. We put in the x value pi over 2. We plug it in here. So 1/2 times pi over 2 equals pi over 4. And then that is the y value in this column. Now we repeat the process. Look how simple it is. One bit at a time. It's like one Lego at a time. Now we're going to add the 3 right in front of it. One little bit of complexity at a time. Yes, I forgot to say graph the green one now. So in the third column here, number 3, we just added the 3. And notice how we already have this coming from over here. So really, we only need to multiply by 3 whatever was in the green column over here, all right? So let's look at this example here in the third row. If we had a 1 on this column, we just multiply by 3. 3 times 1, the 3 is coming from here. And we get 3, and that's the value for this column. And now we graph it up there in the purple line. And now we have the very scary function. We just add the last bit of complexity, which was the -2. So let's look at this third row again. If we had a 3 here, the 3 is right there. We subtract the 2, which is right there, and we end up with 1. So now in retrospect, whenever we input pi into the function, I'm just choosing one value, we end up with 1. So the point will be pi 1 for the very scary function up here. So whenever I plug in pi, I'm gonna get 1 as an answer here. That's just one data point, okay? So pi is here. The color that we assigned was blue. So there's the 1. See how the 1 corresponds? And you just graph the blue one as I did right here. I'm gonna erase the line so you can see the blue. That is how you get from a parent function that we're all familiar with in column number 1 to the more complex function, and we can graph it. One bit of complexity at a time, and we get there. You can implement this method for no matter how complex the function is, one step at a time. It may take you a little bit longer than maybe some of your classmates or some of the people that get it quicker, but you're really using your anchor memory, your long-term memory to solve these problems, and this is going to stick with you long-term. So I really recommend this method. Thank you for watching. If you find this content of value, please like, comment, subscribe, and share with your friends. Rafael Testai.